One other application of this paramagnetic diamagnetic. So you know how the electrons are rotating, either spin up or spin down? They create a magnetic field, right? We said that when charged particles move, they create a magnetic field. And when it's rotating, it creates a magnetic field as well. And so we capitalize on that property to do something that many of you probably have had. It's called magnetic resonance imaging. Okay, so hydrogen. Okay, is hydrogen magnetic? Monatomic hydrogen, is it magnetic? Yeah. Okay, it has one unpaired electron, so it should be attracted by a magnetic field. Now for hydrogen, it's just as equally to be spin up or spin down. You have a 50-50 chance to be spin up or spin down. So in your body right now, Emmy, half your hydrogen atoms are spin up, half of them are spin down. Okay? So what we're going to do is you hurt your knee sliding into second base. And you go to the doctor, and the doctor says, no more monkeys jumping on the bed. So, he's going to stick you into a big machine called nuclear magnetic resonance imaging. So, why is it called an MRI if the name of the machine is a nuclear magnetic resonance imaging? Because when they first built these machines, Brandon, and they're like, hey, Brandon, we're going to put you in this nuclear magnetic resonance imaging machine, people heard the word nuclear and they freaked out. Like, no way you're putting me into a nuclear machine. You're going to make me radioactive, even though it doesn't make you radioactive. So then they wised up and they dropped the word nuclear off. So people go, MRI. Oh, I'll take an MRI. Just don't put me in a nuclear machine. I don't want that. So that's where you get MRI from. So what they're doing is when they put you in here, they put you in a giant magnet. Okay? And when they turn this giant magnet on, it will cause all of your hydrogen atoms in the area that they're looking to all go to the same spin state. Because, remember, they're magnetic, so they all align with the poles, just like your magnets here. The poles will line up. They won't do the... that you can't see that, but that's not... There we go. Those are opposite poles. All the poles will line up in the correct orientation. So all of your hydrogen atoms go spin up. You've got the magnet on. They shut the magnet off. And when they shut the magnet off, half of your hydrogen atoms will flip to the spin down state. And when you flip from the spin up state to the spin down state, so as your knee, the hydrogen atoms in your knee flip from spin up to spin down, they give off a very, very, very weak radio signal. We're talking very, 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 very weak radio signal. But this machine can detect that radio signal. And so they can map all the hydrogen atoms in the area of the body they're looking at. So here's an example of this principle of quantum mechanics, which they discovered in 1920. And basically, 60 years later, in the 1980s, they developed a machine with such a powerful magnet it can cause the hydrogen atoms to flip to a certain spin state and measure the radio waves given off of it when they flip back down. And get a nice, beautiful picture of what's going on inside your knee, Emmy, without having to cut it open. Because before, if they wanted to know what was going on, they'd cut it open, stick in a little lens, and look around. And now they can see what's going on without having to do anything invasive.
Why is it so expensive, though?
Why is it so expensive? I don't know.
It was invented a long time ago, right? Shouldn't it, like, the price be going down?
Oh, the theory came up in 1920. But they didn't have the magnets, they didn't have the computers, they didn't have the detection equipment until probably, I'm guessing, the 80s. So MRIs, and then usually when they first come out, they're very expensive. MRIs probably started becoming more accepted in the late 80s, and now, you know, they're pretty commonplace. I mean, how many of you have had an MRI already? I've had a couple. So I don't know how expensive they are right now, how much it actually costs. That's for a whole different discussion. So